Section 3.2, Differentiability. In this section, we're going to talk about where derivatives exist, but more importantly, where they cannot exist. So we're going to start this section by talking about 4 different places where the derivative fails to exist. Remember in the previous example from section 3.1, we looked at when the derivative from the left is not equal to the derivative from the right, then the derivative does not exist. This happens in a couple places. The first place this is going to happen is in a corner. This is when a graph makes a sharp turn and the slopes change instantaneously. The second place this occurs is what's called a cusp. A cusp is similar to a corner, but instead of having a sharp turn, it's gradual into a sharp corner and then gradual back out. The third place it does not exist is a vertical tangent. This is because the slope of the tangent line is undefined. So if the graph ever has a vertical tangent, for example, an asymptote or tangent inverse, then there cannot be a derivative because slope has to be defined in order for the derivative to exist. And then lastly, a discontinuity. This is because not only does the derivative not exist, but the limit does not exist as well. And in the definition of a derivative, the function must be continuous for the derivative to exist. In example 1, we're going to find all the points in the domain of f of x is equal to the absolute value of x minus 2 plus 3, where f of x is not differentiable. So the first thing we're going to do is we're going to go ahead and look at a graph. And this is something you can generate on your graphing calculator, or you can just know what the absolute value function looks like. So let's talk about where this graph has a derivative and where it doesn't. So if x is less than 2, so if we're over here, we have that the slope of this line is negative 1. So the derivative is negative 1. And then after 2, the derivative is 2. So if I were to graph this derivative, when x is less than 2, it should be negative 1. And we see for the x values here, the y value, or the graph of the derivative, is negative 1. And then all of a sudden right there, it jumps to positive 1. So this makes the derivative discontinuous. So the derivative does not exist at x equals 2. So in this problem, it really helps to think graphically. So we know that y equals the absolute value of x has a corner at 0, 0. So f is translated 2 units to the right and 3 units up. So this puts our corner at 2, 3. So if we look back at the graph, over here we have that m is equal to negative 1. So that matches with this part of the derivative. And then from over here, we have that m is equal to 1. So that matches with that part of the derivative graph. So the graph of the derivative looks something like that, with a discontinuity right here at x equals 2. So because of that, what we're going to say is f is not differentiable at x equals 2.